So welcome everybody to this latest video on 162 Maths, and in this video we will go through the AQA AS Maths exam of 2020, paper 1, section B, which is the mechanics section. Now before we get started, a little reminder that there will be a question breakdown of section B in the description, so if you struggled or couldn't do any of the questions, you can see which topic it relates to. There will also be a link to the 162 Maths contents page, which gives you easy access to all of the videos of lessons on the AS Maths curriculum, along with A2 and links to all the other AS paper walkthroughs. Question 11. A go-kart and driver of combined mass 55 kilograms move forward in a straight line with a constant acceleration of 0.2 meters per second squared. The driving force is 40 newtons. Find the total resistance force acting on the go-kart and the driver. For that, I would start with a diagram and put the mass of 55 kilograms as that force 55g. We've got a driving force of 14 newtons, and then there's a resistance force acting in the opposite direction. Acceleration, if we move in the direction from left to right on the screen, would be 0.2 meters per second squared. So using F equals ma, we would have the forwards force of 14 minus the resistance force that's acting in the opposite direction, and that's equal to the mass 55 times acceleration of 0.2. 55 times 0.2 is 11, so 14 subtract what force is equal to 11, and that would be 3 newtons. Question 12. One of the following is an expression for the distance between the points represented by position vectors 5i minus 3j and 18i plus 7j. To identify the correct expression, what we want to do is consider the distance in the I direction and the j direction. So if we're going from the I direction from 5i to 18i, that is 13i, and if we consider in the j direction going from negative 3j to 7j overall, that is 10j. So from there we need to do 13 squared plus 10 squared and square root for the correct expression, which would be the second one. Question 13. An object is moving in a straight line with constant acceleration a, meters per second squared, over a time period of t seconds. We have an initial velocity u and final velocity v, and that's shown in the graph below. Use the graph to show v equals u plus at. In terms of acceleration, acceleration is the gradient of the velocity time graph, and in terms of the gradient we want to do the change in the y direction divided by the change in the x direction. Now the change in the y direction, if we have these two parts here, so if we look at the change in the y direction, that's the difference between v and u, and if we look in the x direction, we're looking at the difference between t and 0, and t subtract 0 is t. So we have the acceleration is equal to v minus u all divided by t, and then we can rearrange to get v is equal to u plus at. That process is the multiplication of t to leave v minus u, and then add u to at to leave v, and that's just been rearranged in a different order to give v is equal to u plus at. Question 14. A particle of mass 0.1 kilograms is initially stationary. A single force F acts on this particle in the direction parallel to vector 7i plus 24j. As a result, the particle accelerates in a straight line, reaching a speed of 4 meters per second after travelling a distance of 3.2 meters. Find f. In this question then, we want to do several steps. So the first thing is to consider a diagram. So we have our single force F acting on our particle. We have the 0.1 kilograms, and as the force acting downward would be 0.1 g. We have the initial stationary. We have reaches a speed of 4 meters per second. We have a distance of 3.2 meters. So we have elements of Suvat as well. So our S is 3.2, our U is 0, V is 4, and we want to work out acceleration. If we use the Suvat formula involving SUV and A, we're going to use V squared equals U squared plus 2AS. Substituting those values in, 4 squared is equal to 0 squared plus 2 times A times 3.2. That would give 16 is equal to 6.4 lots of A. So A is 2.5 meters per second squared. If we add that onto our diagram, so acceleration of 2.5 meters per second squared. Now we can do F equals ma on the system. So our overall force is that driving force F is equal to mass, which is 0.1, times acceleration, which is 2.5. That gives F as a value of 0.25, and that would be newtons. If we have a look at the magnitude of the vector 7i plus 24j, if we look at the magnitude, which is using Pythagoras on 7i and 24j, so that's using 7 squared and 24 squared, square rooted gives you a value of 25. Therefore, if we have a look at that single force F, it's got to have an overall value of 1/100th of the same vector 7i plus 24j. That vector that is parallel has the same I and j component parts, so we're told it's parallel. So it has the same I and j component parts. It is, however, only 0.25, and at 0.25 that is 1/100th of 25. Question 15. A particle P is moving in a straight line with acceleration a meters per second squared at time t seconds, where a is equal to 4 minus 3t squared. We're told initially P is stationary. For part A, find an expression for velocity of P in terms of t. So we need to recognise that velocity is the integral of acceleration. So we're going to integrate the acceleration formula. So V is equal to the integral of 4 minus 3 t squared with respect to t. So if we integrate, we get 4t minus 3t cubed over 3 plus c. Now when we integrate, we get this constant of integration, this plus c value, which needs to be determined, and we look back at the question where we're told that initially p is stationary. So that tells us initially, so at time equals 0, velocity equals 0. So using that substitution, so v equals 0, t equals 0, we can determine that c is also equal to 0. Using that substitution into here, if you replaced v and t with zeros, then 4 times 0 would be 0. 0 cubed multiplied by 3 divided by 3 would still be 0. That must leave c to be 0. So let's tidy up the expression. So for velocity, it would be 4t minus t cubed, cancelling the times by 3 and divide by 3. In part B, the question says when t is equal to 2, the displacement of p from fixed point O is 39 metres. Find the time at which p passes through O. Give your answer to 3 significant figures. Fully justify your answer. Now, fully justify your answer means to take your answer and show all those algebraic steps. So if we work out then using S, so we're talking about the displacement, so we need to consider S. S is the integral of velocity with respect to time. So let's integrate the velocity, which we've just found. That was 4t minus t cubed, and if we integrate that with respect to t, we get 4t squared over 2 minus t to the 4 over 4 plus our constant of integration, and we need to consider what we are told. So we're told when t is equal to 2, our displacement is 39 metres. So we can replace the displacement and the t values with 2 and 39. Is equal to, if we cancel the 4 and the 2, that becomes 2 lots of 2 squared minus 2 to the 4 over 4 plus c. And tidying all that up, we have 39 is equal to 4 add c, so c is equal to 35. So our displacement expression becomes S equals 2t squared minus t to the 4 over 4 plus 35. Then what we need to do is consider the time for which it passes through that fixed origin point O. So in terms of through O, that would have a displacement of 0. It's back at the origin again. So the question is to solve for t when the value is equal to 0. Now at this stage you should consider tidying up the quadratic, or hidden quadratic I should say. So if we multiply through by 4, we get 8t squared minus t to the power of 4 plus 140. Now there's that hidden quadratic within the 8t squared and t to the 4. So if you were to rewrite that as a second quadratic, you could have a new term being introduced. So you could have 0 is equal to 8y minus y squared plus 140, where y is equal to t squared. and you could then solve that quadratic to find the value of y, and then square root to find the value of t. So if you were to do that, you get two values for t, and then you can take so you get two values for y, and then you can take the square root of that value to find the value for t, or equally you could use your calculator and replicate the same answer. But you get t is equal to 4.06 seconds, and that is to 3 significant figures. The second time value that you would get would be a negative value, which would not make sense in this question since time cannot be negative. Question 16. A simple lifting mechanism compromises a light inextensible wire which is passed over a smooth fixed pulley. One end of the wire is attached to a rigid triangular container of mass 2 kilograms, which rests on horizontal ground. A load m kilograms is placed in the container. The other end of the wire is attached to a particle of mass 5 kilograms, which hangs vertically downwards. The mechanism is initially held at rest and shown in the diagram below. Then says, the mechanism is released from rest and container begins to move upwards with acceleration a meters per second squared. The wire remains taut throughout the motion. We then have a question, show that a is equal to 3 minus m over m plus 7 lots of g. If we go back up to the diagram and add in some of those forces and in the directions that everything is acting, we have our force downwards, which is m plus 2 lots of g, that's the force acting downwards, and we have some tension in that wire acting upwards. In the 5 kilogram mass, we have 5g as the force acting downwards and tension acting upwards. From the description, it tells us that the weight that is the triangular shape is going to move upwards with acceleration a, and the 5 kilogram weight is going to move downwards also with acceleration a. What we have now is a system of simultaneous equations where we have two unknowns, the a and t values, and the first question asks us to find a. So if we set up a simultaneous equation, just do that at the side. So in system, if we look at system 1, which is the triangular shaped weight, we're looking at all of the forces acting upwards, since the system is going to move upwards. So it's our upwards force minus our downwards force. So our upwards force T minus the downwards force, which is m plus 2 lots of g, and that's equal to mass times acceleration. So mass is m plus 2 and acceleration is a. If we then look at the other system where the 5 kilogram force is going to move downwards and our opposing force T acting in its opposite direction, so 5g minus T is equal to mass times acceleration. So there we have our simultaneous equations. Now within this set of simultaneous equations we've got two unknowns, which is T and A, but what we want to do is just find A. Now in order to eliminate T, you could make T the subject and use substitution, or equally you could add these two equations together, and by adding the two equations together, T add negative T will cancel out. So if we add these two pieces of algebra together, we get the addition 5g and minus m plus 2 lots of g on the left hand side of the equals sign, and on the right hand side of the equal sign we have m plus 2 lots of a plus 5 lots of a. And then it's a case of tidying things together. So if we have 5g minus m plus 2g is equal to m plus 7 lots of a. So combining the 2 and the 5, so this 2 and this 5 would give us 7 lots of a, and the m lots of a can stay as it is. And then if we look at combining the 5 minus 2 and combine that, that would be 3 lots of g minus m lots of g. And our last step is to rearrange to make a the subject. So it asks us to make a the subject. So we can have 3 minus m lots of g divided by m plus 7, and that's equal to a, as it's asked us to do. Question 16b says, state the range of possible values of m. If we consider the previous answer, 3 minus m lots of g over m plus 7, we want to find these values of m. So we're looking at the fraction and looking at what values of m can be possible to make this fraction valid. So the value of m, considering it's the mass of something, it has to be greater than 0 for it to have its mass. But if we look at the numerator of this fraction cannot be a negative value. So we cannot have a negative value occurring. So the biggest value of m can be 3. And it wouldn't equal 3, since that would give you an overall value of 0 for acceleration. So we want to have an inequality of m being greater than 0 but less than 3. Question 16c says, the load reaches a height of 2 meters above the ground 1 second after it's released. Find the mass of the load. So we're going to be using Suvat in this case, so we can set up those values, and we have height of 2 meters, so s is equal to 2. It said that the system was at rest, so initially it was held at rest, that was at the start of the question, so u is 0. We've got 1 second, so t is equal to 1, and we want to find the mass of the load. And if we remember, the equation that we were working with was acceleration, so a is equal to 3 minus m lots of g over m plus 7. We want to work out the mass, so we want to solve for m, which means we have to know what a is. So we're looking for a. So using s, u, a and t, we're going to use the Suvat equation. So s equals ut plus half at squared, and we want to find that value for a. So using that substitution, so 2 is equal to 0, lots of 1, plus half a times 1 squared. So a is equal to 4. So now we have a value for a, which is 4. We can use that as part of this substitution. So we can replace the a in this case with now 4. So our value for a. So if we do that and replace a here with 4, we can replace g with 9.8 because it tells us in the question. So we're going to replace g with 9.8. and we're solving this equation for m. So it's a process that we want to go through. So the way that I did this was to multiply both sides by m plus 4. So multiplying 4 by m plus 7. So 4m plus 28 is equal to, I've still got 3 minus m and 9.8 being multiplied together. That's 29.4 minus 9.8m. So multiply by m plus 7 with the 4, multiply the 3 minus m with 9.8. Want to solve for m. So taking m to one side, we get 13.8m. Taking the 28 over gives us 1.4. Solving for m gives 0.101 kilograms. 16D, ignoring air resistance, describe one assumption you have made in your model. You need to look at the description in this question just to see if anything has been left out of the description. You can use as an assumption, but it tells us that the wire is light, it's inextensible, the pulley is smooth, and it's fixed in place. So the go-to answer for this would be, we can assume that the particle, the weight, the mechanism, however you want to describe it. So the particle does not collide with the pulley. The only thing not been mentioned, but as that 5 kilogram weight comes down and reaches the ground, we have to assume that the triangular weight won't reach the pulley before that 5 kilogram weight hits the ground.